evaluate the line integral over c of f dot dr, where c is given by r of t is equal to t squared I plus t cubed j minus 2tk as t goes from 0 to 2. And the vector field f of x, y, z is x plus y squared times I, xz times j, y plus z times k. This is kind of a gift for us because we've been given the parameterization for c. Recall that the line integral over c of f dot dr is equal to the integral from a to b of f of r of t, the parameterization of c, dot r prime of t dt. Now let's put the pieces together here. F of r of t is equal to f of x of t, y of t, z of t, where x of t is the I component of r, y of t is the j component of r, and z of t is the k component of r. And so everywhere we see x, we're going to substitute t squared. Everywhere we see y, we're going to substitute t cubed. And everywhere we see z, we're going to substitute negative 2t. What that's going to look like is t squared plus t to the sixth power, right? So that's our x plus y squared, where x is t squared, y is t cubed, comma, well, I can get some colors here. X is t squared, y is t cubed, so we square that, comma, then we have t squared times negative 2t, and that's coming from xz, where, of course, x is t squared, z is negative 2t. And then the last component is y plus z. Y is given by t cubed, z is negative 2t. And so completing the colors here, we have that vector. Let's go ahead and simplify this middle component here. It's going to be negative 2t cubed. I just didn't want to write out the whole thing. And while we have it in front of us, let's go ahead and get r prime of t, which is 2t, 3t squared, negative 2. Putting this together, we have that the line integral over c of f dot dr, both of them have hats, is equal to the integral from 0 to 2 of t squared plus t to the sixth, negative 2t cubed, t cubed minus 2t, dotted with 2t, 3t squared, negative 2 dt. I'd like for you to go ahead and pause the video and do the work here. Get to the final answer, please. So the dot product, it multiplies the x components together. That gives us 2t cubed plus t to the seventh. The y components together, giving us negative 6t to the fifth. And the z components together, giving us negative 2t cubed plus 4t. We see that the 2t cubes will subtract out. We're left with 2t to the seventh minus 6t to the fifth plus 4t. So after all that, we're simply going to use the power rule, 1/4 t to the eighth minus t to the sixth plus 2t squared evaluated from 0 to 2. And the arithmetic there gives us a result of 8.